All right, so over the weekend, there was a post on Twitter right here, and this person went over a homebrew fake site that then led to the download of some malware. So this ended up being Amos, another Amos stealer, and thought it was a good opportunity to talk about LLDB and some debugging. There was a recent video made by John Hammond that goes over scripting and going into how to decode, the strings. But for this one, we're just gonna kind of skip that and go into debugging and just go using LLDB to read these strings. I think it'll be fun. All right, so this similar thing was brought up before by Alden back in May of last year. So this is not the first time that we're seeing this. Also, last week there was another homebrew site that did something similar, and now we have this one. So I already downloaded this. I put this into a VM so we can debug it. And I also have it on this system here where I'm going to just kind of show Binary Ninja really quickly and focus our breakpoints using Binary Ninja. Okay, so that's all of that stuff. Make this active and let's continue. So this is a quick curl command using the site. Just grabbed curl and I downloaded this file and put it on my desktop, and then I moved that over, and then now we're just going to show this in Binary Ninja. Here we go. Okay, so this was already discussed in the video by John, so we're gonna kind of skip through these strings, but we know that they're being used for something. These are most likely the strings that will then be decoded. What we really care about the most here is how this gets executed, and in order for this to get executed, it needs to get decoded. So we can skip all that stuff and just focus on the arguments that are passed to the system function. So system's gonna run whatever is passed to it, and system accepts. You can actually look that up really quickly. Accepts a command. So we know that in ARM64, that's going to be an X0 prior to the branch and link instruction to system. So what we can do is we can set up our debugging session with LLDB and then target this address, use that for our breakpoint, break there, and then we can analyze whatever is inside of X0 and then see what command was decoded in order to be passed the system. So let's do that. I'll move this over so I can actually target this properly. So I moved it into my malware folder. So LLDB Brew Stealer. Brew agent actually ends up being another one of these. Okay, so LLDB Brew Stealer process launch -s. We're gonna launch it, and we're gonna stop at entry. -s just stop at entry. We're gonna set a breakpoint to the start function. So there's 4 zeros, 3, 4, 4, 8. I do this just to make sure things are working properly. Okay, so now we're going to continue. So we're going to press C, and we're at the start, which makes sense. We should be right here where we're creating space on the stack. And it should be 0x F0. Cool. All right, so now we're going to set a breakpoint to the system call. That's going to be 3550. So another breakpoint, 4 zeros, 3550. Breakpoint, continue. And we're now at that system call. So the system function call. Cool. So we know that in ARM64, the argument that's going to be passed to this function is going to be an X0. So we can look at that. So regread X0, and that's the address here. This is pointing to the stack. So then we can look at what this is. Let's just do like a quick memory read of this location and see what there is. Okay, so we have this disown p kill terminal string here. So this is then going to be passed to the system call, and it's going to then kill the terminal. So we don't want that because we're currently debugging this. This is kind of annoying. What you can do is you can then just change what the PC is pointing to. So PC program counter is pointing here. So what we can do is we can just set it to be this value. So let's do that so that we can skip this. This allows us to kind of just skip this function from actually running this command, so then we don't lose our terminal session here. All right, so what we can do, reg write, we target PC, and just to make sure I don't mess up anything here, we then copy paste that address. And now if we do F to see like our current frame here, we'll see we skipped over that system call or the system function. Okay, so now we want to see the next thing, right? And the next thing ends up being another system function call here. So we skip this one. We're currently at this address. And now we want to come here so we can see what was put into X0, which is going to be, this is Amos, so it's going to be gigantic Apple script thing, but then we'll be able to actually see it. So let's set a breakpoint to this. So that is reg write star PC, and then we want to, oh, actually we're not skipping over anything. We're going to just hit a breakpoint. V 0x1 0 0 0 0 3 5 6 8. You can use reg write to kind of go to the system function call here, but then you skip all the setup prior. So just set a breakpoint, and that is 3 5 6 8. Continue. Now we're at the branch and link instruction before it gets executed, and we know that we can look at X0, it's pointing to this, and we can just kind of take a look at what's there. And then we see a command that starts with this OSA script. So a couple things when you're looking at this, you can do like a memory read, and then you can do like a count of 0x100. And then you can see hex 100 bytes of these bytes here from this memory location. In order to do this type of stuff, I just made a quick note of it here because I forget. There are certain settings that you can check for and set. So if I do like this, this is showing my settings in LLDB. It's set to this value. I can change that. And I can also change my target max string length. So let's see what that looks like when we're actually reading this as a string. So these are both set to this value. You can change them. So if we set this, I don't know, let's say 5,000, or actually I want 0x4920 so that I do this right. And then you can set this to that. And so now we can read, should be able to read this string with a formatted string. So format string and count 0x4920. Oop. Format S. Oh. X. And then we need to do a force. Okay. So if you run into that error there, you have to pass a force because it doesn't want to read all those bytes. And I read more than I need to here, but that's okay. We're just trying to see all these values, so we can just kind of just scroll this up. There's a lot here. And there it is. Okay, so I did not need to read that much, but you can then use this to output the command to a text file and look through it. So this is the gigantic Apple script that Amos uses. We can just output that for fun. Out file and then brew command dot text, and then we can read that. So you do a quick vim, and then if you're looking for like the destination of this, right? So you're looking for anything that has to do with HTTP or any kind of network communication, you can just do a quick search with a / here in Vim and look for HTTP. And then we can see that right here in our text file. We scroll over, we'll see HTTP and then this address and then the join system. All right, so yeah, so that's just some quick LLDB commands so that we can see the output of the actual command that is passed into the system call here for this Infostealer. Cool. Hopefully that's helpful with using LLDB for debugging. Thanks.